Hello everyone, my name is Nivedita S. And today I'll be talking about the Josephus Problem. This is a famous puzzle that is part of both computer science and mathematics. You'll see how a story from history became a puzzle we use to teach important ideas like recursion, loops, and algorithms. So, what is this Josephus problem? Imagine you and your friends are standing in a circle playing a counting game. You start counting around the circle, and every kth person gets removed from the game. This continues until only one person is left standing. That's the Josephus problem, a puzzle about survival through a specific counting and elimination process. The name comes from a historical figure named Flavius Josephus, who reportedly used this idea to save his life during a war. Beyond being a fun game, this problem introduces us to some core ideas in computer science, like recursion, where a function calls itself to solve smaller versions of a problem, then iteration, which involves repeating steps, and modular arithmetic, which helps with wrapping counting around a circle. So, why do we care about this puzzle? Well, the Josephus problem is a classic example of using logic and patterns to solve complex problems step by step. In computer science, many real world uh, problems require removing elements in specific order. Think about scheduling tasks, managing memories, or controlling access. The circular list, which lets us wrap around from the end to the beginning, it is an important data structure in programming, and this puzzle helps us understand it better. Interestingly, the problem also connects to the game theory, which studies how people make decisions to win games or avoid losing. In fields like cryptography, where data security depends on the right order and randomness, ideas from Josephus can help design better algorithms. So even though this puzzle is ancient, it's still highly relevant today in many advanced areas of science and technology. Now, now let me tell you the story behind this puzzle. Flavius Josephus was a Jewish historian living during the Roman conquest. He and 40 of his soldiers were trapped in a cave surrounded by enemies. They decided that rather than being captured, they would form a circle and eliminate every third person until no one was left. Josephus, not wanting to die, used his knowledge of math to figure out exactly where he should stand in the circle to be the last survivor. It is said that he survived by using this strategy, surrendering to the Romans at the right moment. This story isn't just a myth, it shows us how math and strategy can have life changing consequences. It also teaches us that math isn't just number on page. It can be a tool for problem solving in real difficult situations. Now, now let's try an example to really see how the problem works. Let's imagine six people standing in a circle, numbered 1 through 6. Now, the rule is where we are going to remove every second person. We start counting from person number 1. So count 1, that's person 1, and count 2 is person 2. Since person 2 is the second count, they get removed from the circle. Now the circle has people 1, 3, 4, 5, and 6 left. We keep going, starting again from person 3. Count 1 is person 3 and count 2 is person 4. So person 4 is removed next. The circle now looks like 1, 3, 5 and 6. Next we start from person 5. Count 1 is person 5 and count 6 is person 6. So person 6 gets removed. Now we have 1, 3 and 5 left. Counting again from person 1, count 1 is person 1 and count 2 is person 3. So person 3 is out. That leaves just person 1 and 5. Starting from person 5, count 1 is person 5 and count 2 is person 1. So person 1 gets removed. And that leaves us with our last person standing, person number 5. This example really shows how the counting moves around the circle and people get eliminated one by one until only one person remains. Now, let's talk about how to solve it using math and programming. We use something called a recursive formula. This means the answer depends on a smaller version of the same problem. Here's the formula. J of n comma k is equal to j of n minus 1 comma k plus k mod n. This tells us the position of the survivor if there are n people and we remove every kth person. We also have a base case, which means if there is only one person, they survive. So j of 1 comma k is equal to 0. This formula is powerful, but it can be slow for big numbers. So we also use a loop method called the iterative approach. This method uses a simple loop and is faster, especially for bigger numbers. Before we jump into the real code, we write a plan called pseudocode. This pseudocode helps us think through the steps clearly without worrying about the syntax. So here's the plan for Josephus. It will first read all the names and put them in a circular list so we can loop around endlessly. Start from the first person and count up to the kth person. It will remove that kth person from the list and it will continue counting from the person right after the one removed. It will repeat until only one person remains. This simple set of instructions captures the whole process and prepares us to write actual code. Now here is the actual code, the C code. So we start by taking the inputs, the number of people and their names. Then we create a circular linked list where each node represents a person and points to the next person. Then we loop around this list, counting each person until we reach the kth one. When we find the kth person, we remove them by adjusting the links between nodes. Then we print out the names of the person removed so we see the elimination order. Finally, when only one node remains, we print the name of the survivor. So this implementation shows us how an idea becomes a working program that solves the Josephus problem efficiently. Now you might wonder, why should we care about a puzzle where people gets eliminated in a circle? Well, the Josephus problem has many practical uses. In computer science, it's used to analyze and test the efficiency of algorithms. Then these game developers, they use these ideas to design fair rules and strategies in multiplayer games. In cybersecurity, similar principles help decide who gets the access to secure resources and in what order. So it also helps in distributed computing like sharing tasks between multiple computers efficiently. Then, even in everyday problem solving, understanding circular structures and elimination logic can improve how we organize data and resources. So, the Josephus problem is more than a game, it's a powerful tool for solving complex challenges. To conclude, the Josephus problem beautifully combines history, math, and computer science. It teaches us how to break down a problem step by step, use patterns to find solutions, and implement those solutions in code. More than that, it reminds us that math can be practical. It helped Josephus survive a dangerous situation long ago. I hope this gave you a clear understanding of the problem and why it matters today. Thank you all.